we're going to go through and do the basics of the beginning of chapter 1. So we're kind of starting partway through the chapters. So 1.4 is on solving equations, which is a review of what you would have done in Algebra 1. So just some basic understanding before we really get going with equations. An equation is anything that has an equal sign, essentially. Any statement where you have an equal sign. It can have letters, it can have numbers, it can be something like 3x equals 12, or it can be just something like 5 equals 5. It can be a plus b equals c. As long as you have an equal sign, it is an equation. And you'll often see in the directions, when you see an equation, the word that you're going to see the most with an equation is the word solve. Because equations have a solution. Whereas if it's just an expression, if it was like 3x plus 2, no equal sign, you can't solve that. You can maybe clean it up a little bit, simplify it, but you can't solve it. So we have some properties of equations. I'm not going to spend much time on this at all. I think there are some very basic things you should know, but it's never something I'm going to ask you to memorize or recount. So just kind of some quick things. Reflexive property just means anything's equal to itself, like 5 equals 5. The symmetric property is the one that allows us to write in a different order, like if A equals B, B equals A. So if 7 equals X, X equals 7. A lot of times students like to have the variable come first, and in the end, it doesn't really matter. Transitive property is the one that shows us that if A and B are equal, and then B and C are equal, well, my ability to use my mouse is pretty bad, then that means A and C have to equal. Like there's a common thread that connects them. Substitution, you do a lot of times in word problems. You get to the end of a problem and you figured out that the height equals 5. Now you're going to take that 5 and plug it back in. Anytime you hear someone say, well, plug it in, you're just substituting. The bottom 3 are just reminding you what you can do to both sides of an equation. Whatever you do on the left, you do on the right. So if you add a number to the left, you better add that number to the right. If you subtract a number to the left, you better subtract that number to the right. Same thing with multiplication. If you multiply both sides by 6, you better do it on every part of that equation. If you divide both sides by 6, you better do that on every part of the equation. So just being consistent, thinking of the equal sign as like a balance. And if you do something to the left side of the balance, you need to do something on the right. When we're talking about a solution is going to be what makes it true. So in the end, the solution might be something like 5 or 3 or a half, and it's going to be what you can plug back in for the variable to make it true. There are equations that we work with, especially as we get higher into algebra, that have more than one equation, two equations, or two solutions, three solutions, or infinite solutions. So we're going to start with the very simple ones, but solutions can take many different forms. Inverse operations are things that you would have dealt with since probably elementary school. If I asked you what's the inverse of addition, I would hope everyone would say, well, it's subtraction because it's the opposite. And that's really what inverse are. Inverse are things that undo each other. They are things that if you have a plus 3, then you need to have a minus 3 to undo that plus 3. When we're solving linear equations, this is just a checklist, and it's kind of nice to go back and go through the step by step if you need to be reminded of the steps. The first thing you want to do, if you can, if there's parentheses, see if you can get rid of them by distributing. I like to draw a lot of arrows when I distribute. See if there are things on either side separately that can be simplified or combined. So if you have a 2x and a 3x on the same side of the equation, add them up. Same thing if you have a 5 plus a 2 on one side of the equation, add them up. Then you want to get all your variables on one side. I like to call it isolating the variable, and all your numbers on the other. So you get to decide which side you want to work with. And as we do some examples, we'll talk about what I think are easier. You're going to use your inverse operations to undo. The goal, again, is to get the variable isolated. And then when it's all said and done, if you get an answer of x equals -1, then check. See if you put -1 back in for x, if you actually get a balance, if you get both sides being equal. So we're just going to go through and practice. I'm going to take you through some, and then we'll give you a chance using Delta Math to try some on your own. So one-step equations. One-step equations are definitely the easiest. What they mean by that is it's only going to take one operation or one step to finish these. So with something like this, we need to get the x by itself. So to undo the +4, we're going to do -4. Whatever you do on the left, you also do on the right. If you want to cross off what's simplified, you can. -12 minus 4 is -16. As far as checking, it's really nice if you have the aid of a calculator next to you to do a quick check. This one, you probably don't need it. But if you take that -16 and put it back in for x, add 4 to it, you better get negative 12 or else your answer doesn't check. When you're dealing with a variable that is being multiplied by a fraction, and you're trying to isolate that variable. You're trying to get rid of that fraction that's in front. To do that, you're going to multiply by its reciprocal. The reason we do this is if you think of it as dividing, well, now you're dividing by a fraction and that gets really messy. Dividing by a fraction is the same as multiplying by its reciprocal. So that 3 halves times 2/3 will cancel because 3 halves times 2/3 is just 1. That's why we use the reciprocal because it cancels it out. And then we're going to multiply 14 by 3 halves. Here again, you're always welcome to use a calculator in this class if you have it close by, if you have one on your device. You could also do it in your head. You could take 14 divided by 2, which is 7, times 3 is 21. Again, to check to see if that's the right answer, I'm going to take that 21 and I'm going to put it right back in here and say, well, what is 2/3 times 21? And it is 14. Two-step equations, again, these are ones that often have variables on both sides or have extra things like parentheses or like terms. So when I see something like this and I have a number in front, I want to distribute first. I like to draw arrows. You don't have to. So when you multiply the 3 out front, you're going to get 3y minus 9. And I didn't do anything to this side. And then I want to get all the variables on one side and all the numbers on the other. I like to work with wherever my smallest amount of the variable is, and I like to move that one. So I'm going to subtract 3y over here. That will get rid of this. So I have negative 27. 6y minus 3y is 3y equals negative 9. Since I decided that my variables are going to the left, then my numbers need to go to the right. So I'm going to undo the negative 27 with positive 27. So I've got 3y equals 20. I have a negative 9 and a 27. That's 18. Divide both sides by 3. And I get 6. And again, if I want to check my answer, you do have to put the 6 on both sides where you see the y. Begin to check that balance. So if I put 6 into the left and see what I get on the left side, and then I put 6 on the right for y and see what I get, both sides should be equal. Something like this, there's a couple ways to do this one. You can distribute if you want. One thing I often do with fractions is if I can find a way to clear that fraction, meaning basically get rid of any fractions in my problem, it would make life easier for me. So I'm actually going to do that. I'm going to multiply everything here by the reciprocal of 1/5, which is 5. Now, if I do it on the left, I have to do it on the right to everything. So I'm going to put it in parentheses here just to remind myself that all of that's getting the multiplying by 5. So the 5 and the 1/5 cancel. I'm left with 2x minus 6 equals, when I distribute the 5, 5x minus 15. I'm going to subtract 2x on both sides. I'm also going to add 15 on both sides. And you don't have to do it in 2 steps at once. You can do it separately. So on this side, I get a 9. On this side, I get a 3x. Divide both sides by 3. I get 3. And again, to check my work, I need to put a 3 here and here to see that it makes both sides equal. Here's a couple more I wanted to practice. Here's another one. If you want, you can multiply by the reciprocal, but multiplying by 4/3 doesn't really make it better because it's still a fraction. So I'm actually going to distribute this one just to show you another option. I wanted to show you 2 back to back that were kind of similar with different techniques. So I'm going to take 3 halves times 2. Again, you can utilize a calculator if you need to. 3 halves times 2 is 3/4, times 2 is 6/4, which is the same as 3 halves. You can use decimals. You just want to be careful with repeating decimals. 3/4 times 8 is 6 equals 5 minus x. I need to get all my x's on one side, so I'm going to add x here and add x here. So I have 3 halves x plus 1x. Again, calculator can help you if you want. If I have 3 halves, which is the same as like 1.5 x plus another x, I get 5 halves x, or 2.5x if you prefer fractions or decimals. I also need to move the 6, so I'm going to subtract 6 on both sides. So I have 5 minus 6 is negative 1. And then finally, I'm going to multiply by the reciprocal. Multiply by the reciprocal, multiply by the reciprocal. I get x equals negative 2/5. When you're checking this on a calculator, you can type in -2/5 as you see it. Just type in exactly that, -2 divided by 5. You can also use the decimal equivalent and check that. There's lots of ways to work with fractions and decimals kind of hand in hand. For this one over here, we do need to distribute. The most common mistake that students make is they try to subtract first. You have to follow your order of operations. So this -2 has to be multiplied by what's inside first. So we have 5x minus 6, because that's what -2 times 3 is, minus 2x, or minus 2 times -x is going to be a positive 2x. So first we distributed. We can also distribute this minus sign. Sorry, that got really messy. So when I distribute this minus sign, I'm going to get a -4 and a positive x. The minus sign essentially just changes the sign. I'm going to combine like terms here. So I have a 5x and a 2x. Always use the sign in front to know whether it's a positive or negative. So it's a positive 5x and a positive 2x. So that's 7x minus 6. I'm going to subtract x. So I get 6x minus 6 equals -4. I'm going to add 6. So 6x equals 2. Divide by 6, divide by 6. I have a couple options on my answers here. 2/6, it does reduce, so I would prefer that you do put it in simplest forms. Or if you want to write a decimal and grab your calculator, 1/3 is the same as 0.3 repeating, so that's fine as well. I think the fraction is a little easier to write, but that is up to you. And finally, some special cases. Special cases are ones that, just like we talked about, is going to be something different than what you're noticing. So let me show you what's special about these. For this one, again, I'm going to look for, there's no distributing, so I'm going to look for like terms. I have a constant term here and a constant term here, so I'm going to combine those first. 11 minus 7 is 4. I can't do anything with a 3x yet, so I'm going to leave it. On this side, I have a 6x and a minus 3x. I can combine those. That gives me 3x. And what you'll notice here is my first step is going to be to get rid of the 3x. Well, they got rid of it on both sides. So what I'm left with is 4 equals 5, which makes absolutely no sense. In no reality does 4 ever equal 5. I'm just going to put a little line here. What that means is this doesn't work. There's no solution for this equation. There is no x value that I could ever find that I could plug in and make the balance work. You can write the words "no solution." I have a symbol that I love to use, and I'll use it throughout this year. This is my no solution symbol, which is basically telling me I did it all. I'm still not getting an x answer that will work. And then over here, the 6x and the minus 2x is 4x. On this side, the 4 and the plus 1, give me, that should be an equal sign, 5 plus 4x. And what you'll notice on this side is everything is the same. In fact, if I tried to go a step further and subtract the x's, that cancels, and I'm left with a statement that is always true. When it is always true, what that means is any x value I would pick would make this true. So I could pick x equals 2, 0, 5, -1, 3/4, doesn't matter. So there's many things you can do. You can say all solutions, or my favorite way to say this is there are infinite solutions, one meaning any number I pick would work. This is a special case. This is called an identity when this happens. Identity meaning you have the identical thing on both sides and both sides are true. So those are your special cases, and that's just a little bit of understanding with basic solving that hopefully will help you go further.